Anytime they give you a reaction and then they tell you to find the balanced redox reaction, your first step is to use oxidation numbers to find the half reactions. Lead goes from 2 plus to 0, and aluminum goes from 0 to 3 plus. That means that lead is the reduction half reaction and aluminum is the oxidation half reaction. Now write out those reactions with the correct number of electrons added. Once you have your half reactions, you need to get the number of electrons in each half reaction to be equal. And we do this by multiplying each half reaction by a number that's going to make those electrons equal. For this one, we multiply the reduction half reaction by 3 and the oxidation half reaction by 2. Then combine everything on the left side, which gives you 3 lead 2 plus 6 electrons plus 2 aluminum, and then combine everything on the right side, which gives you 3 lead and 2 aluminum 3 plus and 6 electrons. Now cross out anything that appears on both sides, which in this case is just the 6 electrons. What you're left with is the balanced redox reaction. For the more complicated redox reactions, you don't have to go through any of those steps that we did in the last one. However, it is good practice to be able to identify what gets reduced and what gets oxidized in any redox reaction. And you always do that by assigning oxidation numbers. When you do that, it reveals that iron gets oxidized and manganese gets reduced. Now if you try to go through those other steps like we did in the last one, you'll notice that there's no oxygen on the right side of this reaction, and that's what makes us so much more complicated. To be able to thoroughly solve these like you would need to do in a college chemistry class, you'd have to look up how to solve redox reactions in acidic or basic conditions. However, for the MCAT, because it's a timed multiple choice test, they usually don't make you go down this road. And instead, you can just compare the answer options to figure out which one's right. When you're comparing the answer options, you're doing two things. First, you're making sure that the atoms are balanced, and then you're making sure that the charges are balanced. So the total charge on each side of the reaction arrow needs to be equal. Let's quickly do that for each one of these answer options and see which ones are incorrect. If you like these explanations and videos, please click on the link in my bio to check out my MCAT community. Starting with option A, we have 5 iron on the left and 5 iron on the right. We have 1 manganese on the left, 1 manganese on the right, 4 oxygens on the left, 4 oxygens on the right, and 8 hydrogens on the left and 8 hydrogens on the right, so the atoms are balanced. Add up your charges on the left side. We have plus 10 from those irons, minus 1 from that molecule, and plus 8 from the hydrogens, and that gives us a total of plus 17 on the left side. On the right side, we have plus 15 from those irons, plus 2 from that manganese, and nothing else. So we also have plus 17 on the right side. Since the charges are balanced and the atoms are balanced, there's a very good chance that this is your correct answer, and to confirm that, look for errors in the other answer options. With option B, we have 5 iron on both sides, 1 manganese on both sides, 4 oxygens on the left, but only 2 oxygens on the right, so B is incorrect. For option C, we have 5 irons on both sides, 1 manganese on each side, 4 oxygens on the left, but no oxygens on the right. For option D, we have 5 irons on the left and right side, 1 manganese on each side, 4 oxygens on each side, and 8 hydrogens on each side. For the charges, we have plus 10 from those 5 irons, minus 1 from this molecule, and plus 8 from the hydrogens. On the right side, we have plus 15 from those irons, plus 3 from that manganese, and nothing else. In total, we have plus 17 on the left side and plus 18 on the right side. Since these charges are not balanced, we can